Hi everyone, and welcome to this week's community meeting of the Keptn CNCF project. Today it's April 15th, and I have to admit we are a little bit late for a celebration because usually we do it at the end of the quarter, and we are already in the beginning of the next quarter. But anyway, I'm really excited to celebrate something today. But let us just walk through the agenda as always. First part is please everyone that is joining, just add your name in the attendee list, and we are following the CNCF code of conduct here. That's also, I just want to mention this in the beginning of each meeting. That basically means please be nice and excellent to each other in this meeting. So taking a look at the agenda, there are actually no follow-up action items from last week. We moved everything that we had to discuss into PRs and issues, and discussion is going on there. But doesn't have to be discussed in this meeting. There is no concrete blog content out there as far as we know. If you see any new blog content out there, just let us know, and we're happy also to announce this here in this meeting. But there are two new video tutorials out there. The one was just released today, a short video on Keptn in the box and how you can use it and what basically what it gives you in terms of the flexibility and the very fast Keptn installation with the demo project already onboarded and everything for you to be ready to be experienced in this. And then another one is the Keptn resilience evaluation with Litmus Chaos and Keptn. This one was recorded earlier this week, and both of them are also linked in their respective tutorials. So I will also make sure to have the tutorials linked in here. So either way, if you're following tutorials or if you want to just take a look at the video, you will find the content here. So thanks everyone also for joining here. And with this, I think without any further ado, I want to announce our community rockstar of the first quarter of the year 2021. And he's also joining here. It's Adrian, and he did a lot of, thanks for joining, and thanks for all your contributions on the Keptn core, where you helped us to enable custom MongoDB deployments, and not only the MongoDB that comes with Keptn, but to make Keptn more flexible and let's say also enterprise ready to allow custom MongoDB deployments. You helped us also in, I think, in detecting the right version with the version check on getkeptn.sh. And you also already did a great implementation of Keptn in the organization you're working for, where you have Keptn together with basically Keptn having Keptn quality gates as an evaluation of resilience tests, and these tests are a combination of Litmus Chaos and Locust performance tests and load tests. But yeah, for now, I really want to give you the stage to please present your contributions that you have already done to Keptn. I think everyone here is really excited to learn what you've already done. I guess most of the folks that are joining might already know you from the Keptn community, but nevertheless, I'm really excited to see it again, what you have already contributed. And again, thanks so much for contributing to the Keptn project and being part of the Keptn community. We really appreciate this. So with that.
So thank you very much. I have one bad news. The bad news is that our VPN today is not working too good. So I will just sorry for the slides being reused from the previous presentation, but our ENV is not the best today. So I will just so guys, first of all, thanks for this amazing award. I'm really humbled to be the part of such a great community and to have this badge, but of course it's not just a badge. It's a sign of your let's say of your how to say you welcome me as a part of the team, so team community. So that's something super important for me. Unfortunately, right now the time is quite crazy for me because I'm going some transformations, but also as a spin-off from the Keptn community, I made the decision to go back to be closer to QA leading things. So I merged my paths with Kitopi, and Kitopi is the company that basically we were working on the integration in. And one of the reasons why I joined them is probably also Keptn. So that's a that's a good thing. And the other, let's say, a spin-off from this collaboration is that they're gonna use Dynatrace. So we are gonna have even more common points. So as Jürgen mentioned, two, let's say, smallest thing I don't even have on my slides today. I think you can see my screen, right?
Yes.
Two smaller things were the contribution made by the way, let's say. So during this project of introducing Keptn in Kitopi, we realized that it's super easy to use a separate MongoDB instance. So with collaborating with some other people in Keptn project, we were able to give people possibility to use their own existing MongoDB instance instead of spinning the one that was automatically deployed with the Keptn. So basically that's very nice because if you already have, and some folks already have existing instance, so they are now able to use their own instances. Also, we learned that it's pretty much very hard to use DocumentDB, AWS DocumentDB, even though it's mentioned as a MongoDB compatible. For usage with Keptn, it's not so not so close to MongoDB, so that's also a lesson learned. Also, as a second thing, I was able to provide some simple validation for Keptn CLI version selection. So these are the two things, but I'm also proud of them, and it's very nice to work in this community. But the main thing, as Jürgen mentioned, was introducing a very simple pipeline, very simple for now, because as I mentioned, I'm still as a sideman in Kitopi for now, like a session player. But since May we will be working full throttle, so I think we will develop that. But for those who haven't seen that, as the outcome of our work in Kitopi, we were able to come up with a project or a pipeline that basically has 3 stages. We are thinking about those stages as progressive chaos intensity. So the stages represent different, let's say, different conditions in your environment. The first stage would be like a perfect world where you don't have, or you have near zero chaos. The second stage would be a little chaos that you introduce to your system, and we assume this as a light chaos. That means we want it to be something that our system is able to handle. So let's say daily dose of chaos that you still can withstand. And the third stage would be a more dramatic chaos that would most likely cause our system to fail, but we would be able to recover from this chaos. So we have the stages of no chaos, light chaos, so everyday work, daily things, and some more serious failure, which of course would lead to some real failures in system, but also we should be able to recover from that. And we defined SLIs as a request. For now, this is just a request per second for each endpoint. For now, we are monitoring 4 endpoints. Sorry. So the source, I should have put in it in my presentation. So as the source of my test data, we have a locust tests. which is like JMeter test, just basically so load/performance framework that generates traffic. So the traffic is generated for some particular endpoints, meaningful endpoints in our system. And we can, of course, as with any load test, we can steer the number of users, the time between requests, and the endpoints we are hitting. So for us, these are the, like, let's say, these are the indicators that we will be taking into consideration. So taking this, long story short, because this is in my presentation, I don't want to go too deep. We are able to put the data related to load tests into Prometheus. And from Prometheus, we are able to say, okay, so what was the average request per second for each endpoint we are monitoring in a particular stage? And what was the total error rate, or as you say, the average sum of total of error rates for all those endpoints. So this would describe more or less our performance, but also this would describe the error resiliency or error occurrency, more or less. And for the SLOs or the objectives we want to investigate, we assume that the state of no chaos, so the perfect situation, and light chaos, so everyday perturbance, should be pretty much the same. We should not see much difference in our system behavior. So the request per second, whether there is no chaos or the chaos is light, should be pretty much the same. And of course, the error rate should be near zero or zero. For heavy chaos, we are expecting the system to fail, but we are expecting it to recover. Since we are running our tests for, let's say, 5 minutes, and the period of chaos is only for, let's say, 1 minute, the average, of course, for the 1 minute or maybe 1 minute with some buffer, we will have a total failure, maybe 100%. But the average failure rate and average request per second would not be 100% error rate and not zero requests per second. It would average to maybe 50%, maybe 30%. In our case, it's more or less 30 to 40%, and that's acceptable because checking the results at the end, we know that the system has recovered and it was not total disaster, during this time. So in our case, the objectives are pretty much like this. This is only to show you of course, the SLO file or the definitions you already know. If this is the case of no chaos / light chaos. So in our case, if the average RPS per endpoint is above 1.5 requests per second, it's an ideal situation, and it's still not that bad. Means warning when we have at least 1 request per second for a single endpoint. For fail ratios, as I said, the criteria is in ideal situation we want to have below 1%, but it's okay to have this normal fails lower than 5%. While for the stage of heavy chaos, we are expecting the RPS to drop even to 0.2. And in the worst case scenario, we can to some point accept a warning with 50% of fail, but it's not going to be, as I said, it's not going to be 0 requests per second. So it's not going to kill our system totally. And of course, it's not going to cause 100% failure rate. And the final architecture, sorry, maybe I think I should put it as a first slide. Nevertheless, we are steering our pipelines directly from GitLab. And for now, the GitLab is the orchestrator of everything. So it's able to run the tests. The tests are able to store the metrics into Prometheus. Also, after the tests are run via kubectl, we are able to, when the tests are started, via kubectl, we are starting Litmus chaos, which is also putting some metrics in Prometheus. And once the chaos is done, once the tests are over, so in our case, it's just waiting for 5 minutes for the things to finish and then stopping the tests. We are asking politely, dear Keptn, can you please calculate the result of our run? As I said, for now, we are doing it pretty much manually to the tests, kubectl to the Litmus, and of course, via API calls to Keptn CLI, or Keptn API rather. But I hope it's gonna change soon. Nevertheless, we are observing very nice results. You can think about this pipeline like this. So the first stage would be the load test without any chaos, and then evaluating the stage in Keptn. Then as a second job, in the next stage, we have the load tests with some chaos, light chaos, and also evaluation. And as I said, the heavy chaos and evaluation as the third job in our pipeline. So more or less it looks like this. You can see that the pipeline pretty much takes up to 20 minutes, let's say. Also, right now, we are also using a warm-up stage. So basically, we learned that our system during the night, since we are testing our stage environment, our system during the night needs a bit of time to react. So we are using some warm-up stage for 3-4 minutes. We are running some tests, some load, gentle load for the for the brokers to start up, for the database to start the connections, etc., because after some time it just goes to sleep on stage. So now we actually have four phases, and then we are running our stages. So example look of results we are gathering in the tests is like the following. We have the first stage where you observe a very nice situation. The red line represents errors. The green line, of course, represents the requests per second. Then, as you can see, this is stage of no chaos. So you see a pretty much perfect even line. In a second stage, we have some perturbance during the chaos phase, which is one minute. And then everything goes back to normal. And in the third stage, we have pretty much some troubles at the beginning because the chaos is starting. Then the failure rate rises. And of course, the requests per second stay high. Why it stays high? Because our system is responding too fast with errors. So we have errors, and we have, of course, very fast responses or too fast responses with 504s, 503s. And then at the very end, we have, again, very high failure rate. So for now, we are not able to quickly recover from the heavy chaos. It shows that, unfortunately, the pods need to be restarted after chaos. That's why we have the heavy failure rate right here. So if for those of you who are familiar with Litmus chaos, you know that after the tests, if the pods are not going back to normal, Litmus will restart pods automatically, and that's what happens here. Basically, the pods are getting restarted here, and that's why we have this high failure rate, and that's something that needs to be addressed. And as far as the pipeline goes, or the stages in Keptn, as you can see, we have 3 different stages. The light chaos stage, I think this is the older picture where we had a less stable light chaos stage, but no chaos and light chaos, they go pretty much okay. With this heavy chaos, we are having a bit of trouble. So that's something that needs to be addressed, but this is on the developer side. And so far, we've had over 1,000 runs. Every night, we are running pipelines every 2 hours. And we are observing pretty stable behavior to the system. We don't yet see any big changes from deployment to deployment. So next steps. First of all, go back on tracks with this a bit more, because as I said, this is not this doesn't get as much attention as I would like it to have. But also key topping is a bit more SRE, and this is also a topic of switching to Dynatrace. We will not be using Prometheus soon, so we will we will be also going into Dynatrace and using Dynatrace metrics. And we will be exploring possibility of using quality gates in tests, or maybe rather using tests. Use quality gates with tests. Oh, that's going to be a perfect description. So basically, for some of our tests, especially API tests, we would be able to, or we are able to define the smoke, as you probably also have the smoke test suite. And we would like to couple it with some quality gates definitions and use it also as an indicator of a successful or unsuccessful deployment. Okay, I think I went way over my time. So thanks for this wonderful ceremony here. And if you have any questions, feel free to ask now.
Cool. Thank you so much, Adrian. Yeah, I would be interested in actually in this, or maybe if there are some other questions, I don't have to go first. Okay, so I just start. So on slide number 9, for example, is there any other behavior if you have more, let's say, pause or idle time in between those phases? It looks like on when you do the light chaos that there is a little bit of error rate, but just it's hard to see if there's very small around the time.
We didn't explore the times before chaos. That's a very good comment and something we need to address. So there might be a change if we make a bigger buffer between those gaps. Very good comment, but I cannot comment on that yet.
Okay, cool. Yeah, and then I just saw from the screenshots that they are still from the previous version from Keptn, so make sure to upgrade to the latest version. You also get this a sequence screen, and with Keptn 0.8.1, you have like this overview has improved, and
yeah, like
also I think next week
this version is still old, but we are still using older version on in our system. This is like a lot of topics to address and a very small time frame. So yeah. As I said, I'm still waiting for the full transition. So guys, like sleep good tonight. I will do it, but soon, in 2 weeks.
Yeah, I get it. The important part is that the quality gates they're also working for you in the current version of Keptn. And,
yeah, I mean,
it's great to see that you already use it.
For me, like the let's say the SLO calculation, as I said, I don't think I said it before. So few years ago, I was having the very similar task of basically evaluating statuses of some, let's say, API responses, whatever. Like I built a very similar tool on my own. Sorry, not very similar tool. I built a small portion of the logic that is behind SLO evaluation in Keptn, and I know how this how this logic maths and how calculating of percentages and different values that happen to some indicators, how how complex it can get. So really, for me, like this is the winning point of Keptn, that we are able to define with very simple domain-specific language DSL something very powerful. So this is, for me personally, this is the most important feature, even though it's the basic feature. For me, as a person that really cares about the indicators, I don't want to care about all the maths, let someone do the maths. I just want to define it, and that's awesome, right?
Is there any because you just said, you just talked about the maths, you don't really care about it, but is there any let's say statistical comparison or any feature missing from your perspective that you would like to see in the Keptn quality gate, that you maybe not only compare to the previous run, but maybe to or some kind of more complex calculation that you would like to see, or is it fine as it is right now?
No, I think it's okay. I mean, it's, like time series comparison is always a problem, basically, because we are, that we are limited by simple statistics. We are not doing like any rolling average, any, you know, any anomaly detection or whatever. So really, if there is something I'm expecting, would be more anomaly detection. But I know this comes through, for example, with Dynatrace. This is also one of the things why we are going for Dynatrace, because we want to be able to detect anomaly detection. As far as the simple statistics goes, you cannot do anything anything better, because this is all you need to have, like compared to previous results, maybe last result, that's all. You have powerful functions in Prometheus in the queries. If you are using open source, Prometheus gives you all the queries you need. You just need to be, you know, dedicated enough to go to all the documentation and do the maths, right? The calculations.
Cool. And in total, how many SLOs have you defined? Is it those 3 that you mentioned, or do you have more?
I think we still have 4.
Okay.
SLOs are like no, 4 or 5. Sorry, it's 4 endpoints plus the average total error rate. So it's gonna be 5 for now. It's a very small fraction, but it's a usable fraction.
Cool. Yeah, and you said already more than 1,000 runs of the quality gates to evaluate this lightly. This is pretty cool.
And Adrian, but for this use case, you're using the external MongoDB and not the internal one of Keptn, right? And
for this, we are using internal, because our database is DocumentDB, and we were not able to connect it. So we left just the basic, like default deployment.
Got it. Yeah. Cool.
Cool. Are there any other questions?
Just curious.
If not, or we can still ask them, but if not, then I would like to thank you again, Adrian, for your work and for your presentation, and also dedication to the Keptn project. I think now it's also official that we edit you here, our first community rockstar of this year.
Thank you very much.
I linked to your GitHub account here, and also mentioned the latest video you did. So really cool. There is a small gift on it's in the post, so it will be shipped quite soon, hopefully. And yeah, thanks again for your contributions. I think we have covered everything from the agenda today. If there's nothing more here, then I think we can close it a little bit earlier. I think for next week, we will focus on a new release of Keptn, and the Keptn core team will take ownership of this meeting again. And yeah, I think for today, we're all good. If there are any more questions for Adrian, please ask them now. Otherwise, we also have time to Slack in the Keptn community portal on Slack. Thanks everyone for joining today, and have a great rest of your day, and see you all next time. Bye.
Thank you very much, guys. See you soon. Bye.
See you.
Bye.
Bye.
See you.